Hello students, today we are going to take up some problems from HessLaw. The problems were sent to me by some students, so it's something very encouraging sign that students are attempting something and coming forward with the difficulties. For example, the first question is half A changing into B, delta H is 150 kilojoule per mole. Then second is, this is the first equation, second is 3B changing into 2C plus D. Here it is delta H is 125 kilojoule per mole. The third equation is E plus EA is equal to 2D. Here it is 350 kilojoule per mole. And what we are supposed to calculate, it is E plus A. This is what we are going to calculate. It is B plus D, give you E and 2C. Here we want to calculate. So we are having three equations. On the basis of those equations, we have to find out the value of delta H for this required equation. Just see, in this case, first of all, in order to reach at this equation, what we are doing here, first equation is multiplied by 2. First equation is multiplied by 2. It is added the second equation, and the third equation is subtracted. Just see, half A into 2 will be A. This is equal to 2B. Half A is equal to B. A will be equal to 2B. Then when you are adding them, 2B on product side, 3B on reactant side will be left with B only. This will be becoming minus here, so naturally B we are left with. Then we are having, this is A, here it is minus A, so A is no longer appearing here. This is positive A, this is minus A, so this is cancelled. So ultimately you are having this. Okay, here you are having, this is what they call it. In this case, we are getting this. Now we are having E. This minus E will be becoming plus on this side. Then you are having 2D. 2D, here we are having 1D, here we are having 2D. So as a result, this is positive, this is negative. So we are left with 1D only. This is minus D, this is plus D. So plus D and minus D, minus D, minus D will be becoming plus on this side. And 2C will be appearing as such. So as a result of that, what should be the answer? It is 150 multiplied by 2 plus 125 minus 350. So it is 425. Answer should be 75 kilojoule. So this should be 75 kilojoule per mole. So such simple questions they are asking in exam. So here, first of all, half A changing into B. So this is multiplied by 2. So A positive, this is A negative. So naturally this will be cancelled. Then you are having 2B here, 3B here. So 2B on product side, 3B on reactant side will be left with 1B. And then you are having, this is, in this case, this is what they call it D. Here it is 2D. This is positive, this is negative. So this negative will be becoming positive on this side. And we are left with 2C and E. So we are left, this is minus E on this side. It will be becoming plus on product side. So first equation should be multiplied by 2. Then second equation is added. And third equation is subtracted. So this will be giving you delta H from the required equation. So such simple questions are asked in exam, but only those people can solve it, those who have tried it at their places earlier. Otherwise, one is always in trouble. So just see, we are having next question. This is ferrous oxide. This is giving you second question. Here you are having ferric oxide plus carbon monoxide giving you 2Fe plus 3CO2. So this is solid, this is gases, this is solid, this is gases. Here delta H is minus 26.8 kilojoule per mole. This is a reduction of ferric oxide into iron. So reducing agent is carbon monoxide. This is the first equation. The second equation is FeO plus CO giving you Fe plus carbon dioxide. Again solid, gas, gas, solid. Here delta H is minus 16.5. 16.5. Then you have to find out this. We have to find out the delta H for this. Fe2O3 solid plus carbon monoxide give you FeO twice and carbon dioxide. So here we have to find out the delta H. Here we have to find out this. So naturally we require here 2 FeO. We require here 2 FeO, so naturally this equation should be multiplied by 2. This equation B should be multiplied by 2 and it should be subtracted from this. So A minus B into 2. A minus B into 2. So just 2 FeO on reactant side will be give you 2 FeO on product side. Here it is minus, so naturally it will be coming plus on this side. Then you are having 2 CO plus 3 CO, this is positive, this is negative, ultimately 3 positive and 2 negative, 1 CO is left. Then you are having how many iron? Iron in this case you are having, this is 2 iron positive, this is 2 iron negative, so this is cancelled. Then you are having 3 CO2 positive, 2 CO2 minus, so ultimately we are left with this 1 CO2. So here the answer will be minus 26.8 minus, this is plus, minus 16.5 into 2. So it is minus 26.8 plus 31. It is minus, so it is 31 minus 16.8, it is something, it is 33. 33. So answer will be 6.2 kilojoule per mole. So what will be the delta H here? It will be 6.2 kilojoule per mole. For kilo, K should be small. Capital K indicates Kelvin, so for kilo the K should be small. So this is the answer to this. 6.2 kilojoules will be the answer for this second question. So again, here ferric oxide changing into ferric iron using CO as reducing agent. Here iron 2 oxide and ferrous oxide is changing into iron, again reducing agent same. Here ferric oxide is changing into ferrous oxide. So we have to find out what they call it, delta H for this reaction using these two equations. These thermochemical equations are used as algebraic equations. Always remember we have to mention the physical state. This is solid, gaseous, liquid, aqueous, everything has to be mentioned, because if we are not mentioning them, it means that we are not conveying the complete information. So this was the second question. There is one more question. So that is what they call it. Here the question is the heat of formation of ammonia is minus 46 kilojoule per mole. Then bond energy of hydrogen bond is 436 kilojoule. Bond energy of is 726. So we have to find out what they call it. We have to find out the bond energy of nitrogen-hydrogen bond. We have to find out the bond energy of nitrogen-hydrogen bond. So this is the question. So just see, first of all, what's meant by heat of formation? Heat of formation of 1 mole of compound, enthalpy change is taking place when 1 mole of compound is formed from its elements. So half nitrogen plus 3 by 2 hydrogen giving you ammonia. This is delta HF is given by, it is I think standard value 46 kilojoule. So this value is given. Second thing, you are given this bond energy. So what is the bond energy of hydrogen? This is, if you are having this, then this is bond energy is given by minus 436 kilojoule per mole. And if it is like this, H2 changing into 2H, then it will be 436 kilojoule positive. In this case it is positive, in this case it is negative, because here bonds are forming, here bonds are breaking. So this is the difference. Same will be for nitrogen. If you are having this value, it is also negative, 726. So this is minus, this is minus, this is minus, and we have to find out this. So here there are two methods. For example, if you are using this, then heat of formation of ammonia is given by bond energy of reactant, bond energy of product. When you are to use this, when you are using this convention, when you are using this convention, then this is the formula. For example, this is minus 46. What is for reactant? Reactants are, you can say nitrogen and this. So nitrogen half, so it is something 726. This value is hypothetical value. The students have sent away, this value is not right. Anyhow, so this is 726 into half, because for one nitrogen, you are getting this here, delta H bond energy of nitrogen will be 726. So naturally here it should be 300, this is 350 plus 13, 363. So this is the value plus hydrogen. Hydrogen is 436. 436 into 3 by 2. And nitrogen, let us take it up as X. So it is minus 3X. Let us take the bond energy of nitrogen as this, because when this ammonia is breaking, it is changing into nitrogen and 3 hydrogen. 3 hydrogen bonds are broken. So naturally, in this case, this bond energy will be, for this, it is bond energy is for, this will be given by, for each bond it is X, and for 3 bonds it should be 3X. Then dividing by 3, answer will be this kilojoule. So here you will be getting this minus 46. This is 726. It is what they call it, what we have got, this is half will be 300, 363. This is 218, 654. This is 363. Then you are having 654. Answer is equal to 3x. So this should be giving you what they call it 46, and this is giving you 407, and then it is 1061. This is 1061 minus 1, 46 into this, it is 407, and then 409, sorry, 409, and then 409, and then you are having 654, 633. 1063 is equal to minus 3x. So here you will be getting x will be given by minus 263 divided by this minus will be getting cancelled. So it should be what they call it. It is something, it is 35.350. This is 10, this is 16, then it is 4 per mole. So whatever is given, that should be value of, this should be the bond energy of this. Now this method is used when we are using bond energy as bond dissociation, bond breaking. If you use this, if you are using this convention, if you are using this, so naturally उस जगह देखिए बनेगा, then you will be having delta HF will be given by bond energy of product, bond energy of reactant. Then this will be negative, this will be negative, the answer will be also negative. This answer will be also negative because here bonds are forming. So naturally when bonds are forming, then energy is released. When bonds are breaking, energy is supplied. So this is the difference. So here one has to be particular, otherwise majority of the books are writing it like this. So it is this. So here you are having, this is what they call it, minus 3x. So in this case, if you want to use this convention, 2x changing into H2, bond energy is minus 436. Similarly for nitrogen, it will be minus 724, minus 726. So then this value will be coming out to be negative value. So this is the another way of solving the same problem. So I am quite satisfied that students are trying to solve for certain problems. So we'll be continuing with this. So let's have the next video, which is something concerning the next topic. Let us solve it. That's all. Thank you.